The lesson for today is determining if a relationship is proportional from a table. So yesterday we learned about proportional relationships. Today we're going to see if the relationship is proportional if we are given a table. Alright, so let's look at an example. The table below gives the shipping price, so cost in dollars, for a different number of tennis rackets shipped. So this is our dependent variable, this is our independent variable. And we are looking to figure out if it represents a proportional relationship. To test, you find the unit rate for all of the pairs. If they're all the same, if the unit rate is the same, it is proportional. So let's look at the first one. It was $2 for every one tennis racket. So it is already in the unit rate because this bottom number is a per one. So let's look at the next pair. $4 for 2. And once we put that into a unit rate, 4 divided by 2 is $2 for every one tennis racket. Let's look at the third pair, 6 to 3. So $6 for every 3 tennis rackets. That also reduces to $2 per one. And the last, and I believe there is a typo on your sheet, 8 for 4. $8 for 4 tennis rackets also simplifies to $2 per one tennis racket. So it is proportional. Yes, it is proportional because all of the unit rates for each of the pairs is the same at $2 per one. Writing equations sometimes frightens people, but it really is easy. You need to think, what do I have to do to this to get the cost? So how do we figure the cost? We know that each tennis racket to ship is $2. So our unit rate was 2 for every tennis racket. So the cost was $2 for every tennis racket, or C equals 2 times X. And you can test that out to make sure that it works. 2 times 2 was 4. 3 times 2 times 3 is 6, and 2 times 4 is 8. So this is the equation. Alright, let's just take a moment to take some notes. A proportional relationship always has a 0-0 relationship. 0, 0. That just means that both of the numbers are 0. So if you have a table, if you have a 0 at one, you have a 0 at the other. Though sometimes we don't see it on the table. So a 0-0 relationship. To test to see if a relationship is proportional, you have to find the unit rate for all of the pairs. If they're the same, it's proportional. You need to remember to check all of the information. So sometimes we can check 2 pairs and they're both the same unit rate, but a third one might not be. So you need to check all the information for proportionality. And then lastly, to write an equation for a proportional relationship, the rate, so that unit rate, is the coefficient of the independent variable, or the number in front of the variable. So let's do a couple more examples. So first we have to figure out if this is proportional. If it is, what is the unit rate, and then the equation. So again, to see if it is proportional, we're going to find the unit rate for all pairs. So for this first one, 8 over 1, so 8 per 1, and that's dollars per hour worked. This one, 24 to 3, can be simplified to $8 per one. This next one, $48 for 6 hours. 6 goes into 48 8 times, so that simplifies to $8 per one. And $64 for 8 hours also simplifies to $8 per one. So our unit rate was the same for each of the pairs, so yes, it is proportional. Our unit rate is $8 per 1 hour, and to write the equation, I'm going to use just y and x. Y for the amount earned, so this is my y, was 8 for every hour, because in each case I took the number of hours and multiplied by 8 to get to the amount earned. All right, last example. Is this a proportional relationship? So I have the number of cookies made and the number of hours baking. So is it proportional? Again, to test, we have to find the unit rate for all pairs. So for this first one, 50 over 2 simplifies to 25 cookies for 1 hour. For the next one, we have 100 over 3, but that turns out to be 33.3 per 1 hour, approximately. And that is not the same as this first one. So this is no, it is not proportional.